Given ADB is congruent to CBD, and also that AD, this guy, is congruent to BC, I need to show that ABCD is a parallelogram. So there's many ways that you can do this. And I did a video where I used what's called the opposite sides theorem converse. I'm going to use a different one, and you'll see which one I do. Okay, because the picture is a little bit friendlier than the other one that I did. What I'm going to do is I have sides that are congruent. I have angle and angle that are congruent, and I have a shape that looks like a quadrilateral cut into two triangles. So what I can do is use the fact that DB and DB are the same exact thing, and I could use SAS to say that this triangle and this triangle are congruent. Okay, one more time, I could use SAS to say that the triangles are congruent. I'm just making a rough draft over here. Once I say that SAS are congruent, what I can do, you know what? Now I'm going to do the opposing sides again. I already know that AD and BC are congruent, but since these triangles are congruent, I could say that these sides are congruent by using CPCTC. So I could say that AB is congruent to DC by using the corresponding parts of congruent triangles are congruent theorem. Now that I have that, I could say that this is a parallelogram using the opposite sides theorem converse. I was going to do the opposite angles one because I was like, let's do this angle and this angle, but I briefly forgot that, I need this whole angle too and that whole angle too. And I really don't feel like saying like, all right, well, these angles are also congruent. And if I add these angles, I get these angles and then those are congruent too. I would have to add a few more steps, which I don't feel like doing. I'm a lazy bones. All right, let's write our given first. Angle ADB is congruent to angle CBD. Also, AD is congruent to BC, given. All right. In green here, I can say that side DB is congruent to side DB. And the reason for that is the reflexive property. Whenever you say that something is equal to itself, that's the reflexive property. Now that I have an angle in between two sides, remember the angle has to be in between two sides if you're going to use SAS, but I do have SAS. Now that I have SAS, I can say that triangle, and let's go in order. Let's go from the A and go ADB, triangle ADB is congruent to triangle CBD in that order. And what I did was side angle side, SAS. So since this triangle up on the top left is congruent to that triangle at the bottom right, I could say that AB and DC are the same. So 4 is side AB is congruent to side DC. And that is because congruent parts, corresponding parts of congruent triangles are congruent. Last but not least, these sides are congruent. We were told these sides are congruent. That was part of our given. So opposite sides are congruent. Therefore, ABCD is a parallelogram. And the reason for that is the opposite sides theorem converse. Of course, what the opposite sides theorem converse says is the opposite. If the opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. If for some reason you forgot that that's called the opposite sides theorem converse, because that's just a terrible name, then you could say that since opposite sides of this quadrilateral are congruent, then it is a parallelogram. Okay? So there you have it. One more time where we proved that shape is a parallelogram, and we could do that using opposite sides. We could do it using opposite angles, which I thought I wanted to do, but I didn't want to do. There's a way that you could use consecutive angles. If you could show that this whole angle and that whole angle add up to 180, do the same thing with DC. D plus C is 180, C plus B is 180, and B plus A is 180. Then you have yourselves a quadrilateral that's a parallelogram too. You could do that, but it is possible. Maybe not for this one, but that won't happen often. But yeah, this was probably the easiest way to go. Done.